Listen to a lecture in a modern history class.
All right, then. I want to talk about the founding of the United Nations. But before I do, I want to just mention the League of Nations, which was the predecessor of the United Nations. Last week, we talked about the end of the First World War. It ended in 1918, if you remember. Well, right after the war, several leaders of the countries that had won the war, including Wilson of the United States and Lloyd George of Britain, Clemenceau of France, and Jan Smuts of South Africa, and, well, there were others, too. They recognized the need for an international organization, an organization to keep the peace. So when the agreement that ended the war, the Treaty of Versailles, it was called, was signed, it included a provision that included formation of the League of Nations. Its headquarters were in Geneva, Switzerland. But the problem with the League from the beginning was that some of the most powerful nations of the time never joined. As I said, the main drive, the main impetus for forming the League came from Woodrow Wilson, President of the United States. But during the 1920s, the United States went through a period of isolationism. In other words, it just basically withdrew from international affairs. Wilson worked and worked to get the U.S. Senate to agree to join the League, but he never could. Other powerful nations joined, but then quit or were kicked out. This included Brazil, Japan, Germany, the Soviet Union. The other problem was, the League of Nations never had any power, really, no power to enforce its decisions. It had no armed forces. It could only apply economic sanctions, boycotts, and these were pretty easy to get around. The League of Nations did have a few successes early on. It helped prevent wars between Bulgaria and Greece, Iraq and Turkey, and Poland and Lithuania in the 1920s. And the League also had some success in refugee work and famine relief and so on. Oh, and it brokered some deals, some treaties to get countries to reduce the size of their navies. But the League was totally powerless to stop the buildup to the Second World War in the 1930s. So, during World War II, the League didn't meet. Then after the war, it was replaced by the United Nations, which, of course, was headquartered in New York City. Still, the League of Nations was, I think it served an important role. It developed a new model of internationalism. In the late 19th and early 20th century, internationalism really just meant alliances of powerful nations, and these alliances often dragged other countries into conflict. That's what happened, really. That's what led to World War I. But the League was at least an attempt to bring all the nations of the world together to work for peace. True, it didn't work, not really, but at least there was an effort made. Oh, and another thing I meant to add, the structure of the League of Nations, the administrative structure, the government, if you will, was very similar to that of the United Nations. The Secretary-General, the Secretariat, the General Assembly, the Security Council, these are all fixtures of the United Nations that came from the League of Nations. Okay, we're going to have to wait until next class to discuss the United Nations, but I just wanted you to be aware of the League of Nations because of its role, its place in history, which I think has often been misunderstood.
Now get ready to answer the question. You may use your notes to help you. Question 8. What is the main subject of this lecture? Listen to a lecture in an environmental studies class.
Let's go ahead and get started. I'd like to finish up our discussion of alternative energy sources this week. Remember our definition of an alternative energy source? It has to be environmentally friendly, or non-polluting in other words. And what else? Renewable. Not like oil or coal. When you use those, bang, they're gone, they're used up. Renewable sources keep replacing themselves. Okay, so we discussed solar power and wind power one day, and tidal energy, energy from the waves, hydroelectric power from waterfalls, we discussed that too. And in our last class, we talked about one kind of geothermal energy, hydrothermal energy. That's the energy that comes from hot water, from hot springs under the earth. In places like, say, Iceland, parts of New Zealand, where you have these features, this can be a very good source of heat and power. But unfortunately, hot springs aren't found all over the world. Okay, well, there is another source of geothermal power called hot dry rock. That's hot dry rock, or HDR. Ever heard of it? No, eh? Well, the chances are you'll hear a lot about it before long. How does HDR energy work? Well, in theory anyway, and let me stress I say in theory, it's pretty simple. You use oil well drilling equipment, big drills, and you punch 2 holes down into the earth about, maybe 2 miles, 5 kilometers maybe. That's about as far as you can drill into the earth for now at least. Down there, deep in the earth, there is this extremely hot cauldron of rock, of granite. So then, you pump water from the surface into the first tube. The water goes down to the hot rock and becomes superheated. Then, the superheated water rises up the second tube. I forgot to mention that these 2 tubes are interconnected. This hot water rises up the other tube and you use that to heat up a volatile liquid. Do I need to go into what I mean by that? No. Okay. So then this volatile liquid turns into a vapor, a gas, and you use it to turn an electrical turbine and, bingo, you have electricity. And then, when the water has cooled down, you just send it down the first tube again so that you don't waste water. So, does HDR technology meet our criteria for alternative energy? Let's see. Is it environmentally friendly? You bet. There are no toxic gases, no greenhouse emissions, no nuclear wastes. Is it renewable? Sure it is, because the earth automatically replaces the heat that is used. Here's another possibility. If you built a big HDR facility by the seacoast, you could pump seawater down one tube. The seawater is heated way past boiling, so you could separate water vapor from the salt and other minerals in the seawater. After you used the hot water vapor to generate electricity, you'd have pure fresh water for thirsty cities nearby, and as a side effect, you have the salt. Now, will this work everywhere? No, conditions have to be just right. You have to have really, really hot granite masses no more than about 5 kilometers below the earth. We know there are places like this in Australia, in the southwestern United States, in France, a few other places. There are probably a lot of other sites too that we are not aware of. In fact, there may be a lot of HDR sites, and who knows how important a source of power this may turn out to be. Right now, engineers are building a small prototype HDR station in southern Australia and one in New Mexico. These could be up and running in a decade or less. Of course, getting started will be expensive. Drilling a hole that far into the ground, building generators, all of that will cost lots of money. But the way oil prices keep going up, HDR energy production could become more and more financially attractive. Okay, I'm going to hand out a diagram of what one of these prototype HDR facilities looks like, the one in Australia. And then once you've had a chance to take a look at it, we'll talk some more about it.
Now get ready to answer the question. You may use your notes to help you. Question 9. What is the main idea of this lecture?